All right, everyone. So this morning we are going to be starting a new topic. We stopped. Well, we finished up trigs and bearings this Monday, and so you know, as usual with any of those topics, um, you're going to need to make sure that you practice, practice, practice. And I know you have the document that's sent in the group as well as a link to a site that has examples and questions. Now that we have moved on from tricks as far as teaching in the class is concerned, the onus is on you to go out and to practice and to make sure that you are keeping your skills sharp. And as I said to you before last week, that if you, while practicing, if there is any if there is any question that you come upon that you don't understand, even though we're past the topic, it is fine. We can always help you when we come to the class. If you don't understand and you bring it up, we'll always help, right? So it's an ongoing thing, not because we're done with the topic as far as teaching is concerned. Doesn't mean that, going forward, if you need help with a question, we won't help you. So that is how, I want you guys to approach it. You can do the questions and then you can come and you can ask for the ones that you are not so clear on, all right? So today is brand new topic. We're going to be starting functions today. And what a function really is just a relationship between a domain and a range. So to help you better understand a function, I am just going to use an arbitrary example to explain the concept, just to explain it practically, and then we can move on. We can move on to working some questions, all right? So let's go. Let us say I give you this formula here. Now, this is a physics formula, which is not relevant, but I just want you to know what it is about. In this formula, I'm just going to write them over here. In this formula, what is this? P is equal to pressure of a gas K is equal to, K is a constant, the physics constant. That means the value of that remains the same. I always know it. And V is equal to the volume. All right. Now you have this formula. Everybody following me and hearing clearly? You have this formula, and let us say this is because this is talking about pressure, right? And the relationship between pressure and the pressure of a gas and the volume of a gas, where K is a constant that you always know and it's always the same. All right. So let us say this formula is in relation to tires on your bicycle. Let's say you have a bicycle and this formula relates to that tire. So let us say you want to know, what's the relationship between pressure and volume. So for example, if you have a particular, well, let's say if you have a particular volume of gas in your bicycle, you want to know what that pressure is. So let's rewrite this just to say that that constant that we spoke about, let's say that that constant is 10, right? And it's going to be always 10 because it's a constant, right? Now, oops, sorry. So over here, we have our domain. Over here, we're going to have our range. And I just want to draw some numbers. 5, 10, 1. You get the picture. And I'm going to put in all of the numbers for the sake of time. All right. So this is our what we call a mapping, just a simple mapping diagram, right? And our domain is P, which is the pressure that we're talking about. And our range, well, our domain is V, sorry, which is a volume, and our pressure is P. So what we're going to be looking at is just as a just as a random example. If V equal 1, because you want to know how does the pressure of your bicycle tire changes with volume. So if V, and I'm going to ask you to work this out for me. If V equal 1, what is P? Work out this equation for me. If V equal 1. And once you work it out, please tell me the answer. What number that out yet? If V equal 1, what is P? Hello? If V equals 1, what is P?
Would be equal to 10.
P is equal to 10. Good. Let us say if V is equal to 2, what is P?
5.
5. If V is equal to 3, let's not use 3. I don't want to get a odd number. If V is equal to 5, what is
2.
P?
2.
And if V is equal to 10, what is P?
1.
1. All right, so let's work with these now. Let us say, right? So remember, we're using this formula. We're using this formula here. P equals 10 over V to find out the relationship between pressure and volume in your tire. So based on this formula here, if V is equal to 1, which means that if the volume of air in your tire, because this is you going to the bicycle shop, pumping some tire pumping some air into your tire. And think about it like you saying to yourself, I want to have a pressure of 10 into my tire, right? So you say, if you put a volume of 1 amount of gas in it, you're going to have a pressure of 10. A volume of 2, you're going to have 5. 10, 5 volume is 2 pressure, and so on and so forth, like we just worked out a while ago. Now, if I'm to represent this on this mapping diagram here, and it's a very rough mapping diagram. V is our domain. So 1, where when V is 1, P is 10. Let me just choose a different color just to show the mapping. So when V is 1, P is 10. So V will map so 1 in the domain maps to 10 in the range, which is P. When V equals to 2, P equals to 5. So if I can find 2 somewhere here, when V is equal to 2, P is 5. When V is 5, P is 2. And when V is 10, P is 1. All right? So this is your rough mapping diagram here. So when it comes to functions, I want to make a few points. So you can think about, I'm just going to I'm just going to erase just this so I can put some notes there. When you think about your function, right, you can think of your domain as sort of an input, what you put in. You can think of your formula. You can think of your formula as your output, what you get out, and your function, I like to think about it as something in the middle here, right? Which is what you would call, I'm just going to call it loosely, the formula that you use, right? So you have an input, which is an initial number. You put that initial number, right, into a formula, and then you get an output. And that's a simple concept of a function, a very basic, simple concept of a function. Now, in our case here, our input, which we refer to as the domain, that input was our volume because we had values that we used, that we put into the equation for our volume, right? And the function would be this formula here, P equals to 10 over V. And then the output would be the range, which is the values that we got over here. Everybody following? Everybody following?
Okay.
That not quite sound like everybody. So simple enough, this is what a function is. You have an input, you put that input into a particular function, what call, and then you get an output, which is a number that comes out. The input, what I am loosely calling the input, is referred to as the domain, and the output is referred to as the range. Any questions so far? All right. So let's move on now to using an actual function, and just to write and see how functions are denoted. All right, so usually functions are denoted in one of two ways. You will see it written like, and I'm going to be using a particular function here, just a simple one. Or you can see it written as which represents the very same thing, right? So this is read as f of x equals to, f of x is such that x is mapped onto x plus 2, or f of x equal x plus 2, and this is read almost the same way. This is read f is such that x is mapped onto x plus 2, and this one is read f of x equals to x plus 2, which really works out to the very same thing. So when you get a question, let's say we're using this function as our example now. When you get a question to work, you get this, which is how you define the function, just like how we defined what the relationship between the pressure and the volume is in the initial question. This is how the function is defined. So it is defined in such that you would end up putting a value here, which would be your input, which we said your input is your domain. So you'd have a domain values. When you plug those values into x plus 2, you would get an output, which would represent your range. So let us say, for example, if f of x equals to x plus 2, and the domain, you get the domain, which are the input numbers, the domain of x is question says state the range. Right? So remember, the range is the output, right, that you will get from this. So in order to find the range, you'd have to plug each of these values. Let me just take out this, just so that you can get some space. So what we would have to do is to just plug in the domain values, because these are the input, remember? So these would be the input. So we're plugging in these inputs into the formula and getting some output numbers, which is the range. And by doing that, we can answer the question. So to plug these values into the input, it is as simple as saying the function is defined by saying f of x is equal to x plus 2, right? Which means that your f of -1 is equal to, what that means is that anywhere in the function, the definition of the function, that you see x, you put -1, because -1 is one of the domain values. So f of -1 equal to -1 plus 2 equals to, what's this now? +1, right? -1 plus 2 is +1. And then you can go again. I don't know where to write it. Let me write it here. F of 0 equals, again, let me just write back the function, x plus 2. That means f of 0 would be 0 plus 2, because you're putting 0 where you say x, and then your answer would be 2. F of, and I'm getting these values from this domain here, because the question stated what the domain values are, right? So I've done -1 already. I've done 0. Let's do 1 now. So f of 1 is equal to, 3. Next one I'm going to do is 2. So f of 2 . And the last one is going to be f of 3, which is x plus 3 equals to 3 plus 3 equals to 6. All right. So now that I've found all of these range values, now that I've found all of them, sorry. Now, the answer to the question had asked initially to state the range of x. So I'm going to do that now. State the range of x. Just write it here. Give a different color. So the range of f of x is equal to, and I can put it in a bracket, 1, 2, 1, 2, 3, 4, and 6. All right. So effectively, what you've done, you had these input values, which is the domain. You plug them into the definition of the function, which was x plus 2, and you got a set of output values, which we call the range. All right. So everybody understand that?
So far.
Everybody? All right. So, all right. So we can also do this, represent it in a table. Sorry for my table, where you have your x, your f of x, your x values, which would be your input. In this case, it was -1, 0, 1, 2, and 3. So you have those x values, and your output, which would be your range values, which would be, we got 1. When we did -1, we got 1. When we did 0, we got 2. When we did 1, we got 3. When we did 2, we got 4. And when we did 3, we got 6. So you could also represent it in a table as well. All right. But of course, you'd have to label this table by saying f of x equals to x plus 2. So you know what function you're dealing with. Because, you know, this table by itself could go for anything, but you have to
Yes.
put, yes.
Check back the last one. The range
Last one
for
is
3,
wrong.
where you have x plus 3
Oh, it's
isn't
x plus 3 is x plus
x plus
2.
2.
Sorry. Yes, thank you. So this is x plus 2. This is 5. All right, thank you very much. All right, so everybody is good so far? Any questions so far? All right,
I'm good.
so you're good. Amoy, Giovanni, good. All right, so let's work a question together. You can write it out. All right, so you can write that off. You can start attempting it if you choose. I'll work it out in the next minute.
Miss, that sign would mean greater than or equal to.
Yes. All right. So let's see how we go through working this one out. So we have here the definition of our function, f of x. Oh, f of x is 4x plus 5, right? And we also have the range for our function, which is this, the domain value, sorry. And we're asked to state the range for this particular domain. So this is x is greater than or equal to 0, and x is less than or equal to 5. So effectively, the domain values are between 0 and 5. So let's start so we have to first work out each of the domain values in order to state the range, to get the range values, all right? So let's go. So f of x, I'm just going to put that big up here. F of x is equal to x squared minus 4x plus 5. I'm not going to rewrite it. So that's why I'm just putting it up top here and just highlighting it, because I'm not rewriting it again, just for space purposes. So that's our function there. So it means that f of 0 will be equal to 0 squared minus 4 times 0 plus 5, which is equal to 5, because 0 times 0 is 0, 4 times 0 is 0, and we're left with just 5, right? F of 1 is equal to 1 squared minus 4 times 1 plus 5, which is equal to 1. Is this minus? Let me just double check. Yes,
1 squared minus 4.
I don't know why I put plus right here. So 1 minus 4 plus 5, right? 1 minus 4 plus 5 is going to give you 2. So that is that for f of x, right? Because you'd have negative 3 plus 5, and you'll end up with 2. F of 2 will give you 2 squared minus 4 times 2 plus 5 equals to 4 minus 4 times 2 is 8 plus 5. This will give you 1. 4 minus 8 is minus 4. Yeah, it is 1. Good. Next one is f of, where was I? 2. F of 3 equals to 3 squared minus 4 times 3 plus 5 equals to 9 minus 12 plus 5. That looks like 2. 9 minus 12 is 3, minus 3 plus 5 is 2. 5, so yeah, 4 squared minus, no, 4 times 3, sorry, I shouldn't put that in a bracket. 4 times 3 here plus 5. 4 fours is 16 minus 4 threes is 12 plus 5. 16 minus 12 gives you what? What's that?
4,
Plus 5.
9.
Well, that's minus 16. Is it minus 16? Minus 4x. This is 4 right here. Minus 16.
4, 16.
Yeah. Equals to 5. Because 16 minus 16 is 0.
Yeah. 5.
And then the last one is f of 5 is equal to 5 squared minus 4 times 5 plus 5. So you have 25 minus 20 plus 5. And I think that will give you 10. All right. So now that you've found all of these domain values, so you have 5 here, 2, 1, 2, 5, and 10. You can use the table, right? I'm just going to have to do another slide. No. That's a new slide. So I'm just going to plug them in on this new slide here. So you can write your answers for just by saying, sorry, I'm still on that. The range of f of x is equal to, you put them in a bracket, you can say 5 2, 1, 2, 5, 10. You can also put it in the form like you got the result, like just the same form like you got the range. Remember, you got the range 0 in one, the one that's highlighted in green. It was 0 less than or equal to that. You can also write it as that as well. In our case, we would have 1 and then 10. X in the middle, we would have to be less than or equal to, greater than or equal to 1, right? X would be greater than or equal to 1, and then less than or equal to 10. So you can write it that way, and you can do the table. So I don't remember the values, the range values, but you can, you get the point. You can put them in. So you have 0, 1, 2, 3, 4, 5. And I thought you get 5, 2, 1, 2, 5, 10. All right, so that would be what the range is for this question. All right, everybody good so far? Any questions? Great. Next question. So I'm going to leave you to work these on your own, and then you will tell me what your answers are. And if everybody gets the answer, we don't have to work it through. If f of x is equal to 5x minus 2 all right, so go ahead and find the values for the function using those domain values, please. Through these, let's work through these ones very quickly. So we have our function here. What's happening? We have our function right here. So all we are going to do is just put these particular domain values that we're asked for, x values, into the function to see what the output, what the range value would be. So this would work out to be 5 times 2 minus 2, which is 10 minus 2, which would be 8.
8.
You got that?
Yes, miss.
All right, good. The next one would be negative 3. So we're putting it in 5 times negative 3 minus 2. This is negative 15 minus 2. I think that answer would be negative 13. Everybody got that one?
Yes, miss.
No, negative 17. Negative 15 minus 2 and negative 17. What you got, Jevan? Negative 15 or negative 17?
I made a mistake. I got positive 13.
Oh, okay. So be careful of the signs. And
Hello?
just watch the signs, right? Make sure you police your signs.
Oi.
To make sure that
You know what they police?
to make sure that you're doing the right
They
thing.
think you have find 3. Where we upon?
All right. So
All right.
our
3
next
or it can me get 4 of them pound and a half. That's all right.
She just muted. All right. So f of 0. So we're putting in 0 into the function now. Minus 2. F times 0 is 5 times 0, sorry, is 0 minus 2. So our answer would be minus 2. Everybody get that one?
Yes, miss.
Comfortable? All right, one last one like this. And then we move on. All right, so those are the 3 that we're going to end this section on. So I know it looks a little different because now you have algebraic terms inside, as your domain values, but try and apply the very same principle. Anywhere, anything that is in your domain, anything that is your domain, it gets placed right into the function here. So attempt it, and I'll give you about 2 minutes or so to do the first 1 or 2, and then we'll go through them together. You think so? All right, what did you get?
12x plus 5.
All right, how about Amoy and Giovanni? Did you successfully attempted the first one or attempted it any at all?
Yes, I did. I got the same answer.
All right, you got the same answer. Amoy?
Same answer.
All right, great. So this is now 2x is now our domain value. So we're going to use that anywhere we see x in the function. So we have 6. We're going to put 2x here plus 5. X times 2x is 12x plus 5. Simple as that, right? Next one, the same principle. We're putting x plus y anywhere we see the x. So we have 6 x plus y plus 5. So multiply 6x And then that 6 also multiplies the y. 6y plus 5. And that is our answer for that. Anybody attempted the last one, this last one?
Yes, miss.
Yes, miss.
What will you get?
I got 18x minus 7.
All right. Giovanni? Giovanni, now finish it, it look like.
18x plus 3.
Plus 3. All right. So you have the plus 3 part is wrong. So let us see. I think you probably added and subtracted. Just check over your integers. You're subtracting and adding and subtracting negative and positive numbers. That may be what is off. So let's do it and see. 6, 3x minus 2 plus 5. So if you go like this, that is 18x minus 12. 6 times negative 2 is minus 12 plus 5. You end up with 18x minus 12 plus 5. Then you have minus 7, right? So that is our answer. Simple enough, right? Any questions, Giovanni? You saw where you went wrong?
Yes, yes.
All right, good. So we're going to take it up a little notch. No, we're going to do composite functions. So we've just been doing simple functions all along. We're going to just take it up and do composite functions now. So composite functions are just basically functions being multiplied together, right? In different ways. So for example, if I have two functions, one of them is f of x and the other one is f of g. No, that's not right. G of x. One is f of x and one is g of x. Then I can have composite functions that goes g of fx, and I can have f of gx, right? And I can also have g, right? And I can have just composite function. So it's a function multiplying by themselves, just like we're gonna have 3 times 2 or 2 times 2. You understand? This now is what a composite function is. So the question is now, how do we go about working out a composite function? So we're going to do that using simple functions first, and then we can go ahead and increase the level of difficulty. So let's start with a function, two functions, because we're doing composite functions. So if you have one function, which is f of x equals to 4x plus 3, and we have a second function, which is g of x equals to x squared. So let's say you're asked to find f of g4. Let's do that one first, f of g4. Now there are two ways you can do this, and I'm going to show you my preferred way first, and then I'm going to show you the other way. Just bear in mind that a preference doesn't mean that that's the only thing that is right. Yes, both ways can work. Well, I'm just going to show you my preferred way first, and then I show you the second way you can work it, and then you can choose your preference based on what you are most comfortable with. So my preferred way is to go ahead and just define what the function for fg would be. That is how I like to work it. So just like when you have f of x equal 4x plus 3 and whatever, I like to find the function. What is that formula, quote unquote? What is that expression that for f of g? So how do you do that now? First, you put down your f function, right? Because you have the f function out here. So my f function is 4 x plus 3. And then I'm going to put my g function into my f function. Everybody seeing that? That's what f of g means. Means you have f of x here, and you're being asked to put g into this f function. So anywhere you say x, you're going to put your g function. That is putting g into your f function. So anywhere I say x, I put my g function, which is x squared plus 3. So my f of g function now is 4x squared plus 3. That is my f of g function. So I can say f of g, my f of g function is 4x squared plus 3. So just like how I have f of x, g of x, I now have f of gx, yes? The question though is asking me to find, the question is asking me to find f of gx 4, which is that. So what I need to do now is to say f of g4 is equal to, my f of g function is 4x squared plus 3. So 4 times 4 squared plus 3 equals to 4 times 16 plus 3. 4 times 16 gives you what?
64.
How much you get?
64.
4 times 16,
4
yes.
times 16, 64.
64, great. 64 plus 3 gives you 67. Yes? So that is how I prefer to work it. And I just stressing one that is a preference and one that is just one of two ways to work it. So I like to first find f of g, what that function is, and we got that here. We work that out. And when you see that, you're putting the g function into the f function. So we first wrote out our f function and then put our g function into it, which was this x squared. So anywhere we saw x in the f function, we put our g function there, and this is what we got. And then the question asks for f of g4, so we just put 4 into the f of g function that we formed. Everybody understand that? Huh? Everybody good? All right, now. So have you written this off? Because I'm going to change the slide now to show you the second way to work it. So no, I think I'm going to rub it off because I want to keep the functions up here. All right, let me just. What is happening? Whoa. All right, so let's go. So the second way to work it is just to work it one function at a time, right? So initially, I had found the f of g function first, and then I put 4 into it. But now, what I'm going to do, I'm going to now find g of 4 first, which is that. So let me find g of 4, the g function. The g function is x squared. So I'm going to have 4 squared equals to 16. Yes, that's my g of 4 function. And then now I find f of whatever g of 4 is. So I found g of 4 to be 16. So I'm going to find f of 16, right? F of 16, f is 4x plus 3. So then it would be equal to 4 times 16 plus 3, which is the same thing that we had the last time. And we end up with 67. Now, again, it's just a matter of preference, right? The reason I prefer to work it the first way, which is this way, is because a lot of questions will give you two functions. Then they would say, you know, part one would say, for example, find f of g. Part two would say find g of f. And then the other one would say, part three would say find f of g4. So you would end up, you would have to work f of g anyways. Some persons sort of run away from working out the composite function, but some questions, the way how some questions are set up, you have to work out the composite function one way or the other. And so I just always think it's good practice to work out the composite function, all right? But you don't have to. You can work it this way. Do g of 4 first. Whatever value you get, f goes into that value. See, well, that value becomes the input, the domain for the f function. All right? Questions? Anybody don't understand? Because I'm going to give another one, and it's going to get more and more complicated as we go along. Any questions? All right. So let's move on then. Get everything one time. Great. All right. So our next question says to find g of f. So g, no, g of f negative 3. So again, I'm going to work it both ways. I'm going to start by first finding what the function, the composite function for g of f is. So what is happening here is that you have your g function and you're putting your f function in it. So I'm going to put down my g function first. G of, basically you're putting the f function into your g function. So anywhere, so I'm going to end up with f. That's basically what it is. I'm putting the f function into my g. So what my g is x squared. So I'm putting the f function, which is 4x plus 3. That is squared. So I'm going to work this a long way, which is 4x plus 3 multiplied by 4x plus 3, because that is what a squared is. You multiply something by itself. So 4x times 4x gives you 16x squared. 4x times 3 gives you positive 12x. 3 times 4x gives you another positive 12x. And then 3 times 3 gives you a 9. Everybody following so far? I hope you are. Then you will have 16.
Let's start over.
Start over?
Yes.
All right. So this question is asking us to find g of fx minus 3. And I'm working it both ways, but the first way I'm working it is to find a g of f function, yes? Which is to say, I'm finding, just like when you get 4x, f of x is 4x plus 3, g of x is x squared. We want to find out what is g of f for a function, which means when you see it put like g of f, it's like you have the g function and you're putting the f function into it. So you have the g function. So I'm going to put down the g function, which is g of x equals to x squared. But in this instance, the x here is going to be our f function. So I'm putting the f function into the g function, right? So anywhere I see x in my g function, I am putting my f function. So this is my g function. This is x squared. So instead of having x, I am putting my f function. That's what I'm finding. I'm finding gf, right? So my f function is 4x plus 3. So I just substituted x for my f function, yes? And that is squared, because that's what the g function is. The g function is x squared. My x in this instance is the f function, because I'm finding gf, and that's squared. Follow so far?
Yes, ma'am.
Right, so just think of it as putting f into g. So what I usually do, until you get to understand it a little bit more better, whatever is to the leftmost, I put that down first, which is g functions. I put the g function first, and then I put the other one into it. So wherever I see x, I put this function into it, in which case that is 4x plus 3. So that goes into the x function, right? And then this is 4x plus 3 squared. So I was just saying I'm going to work it the long way, which is to say anything squared is multiplied by itself, yes? So if you had 3 squared, it would be 3 times 3, no?
Yes.
So I have 4x plus 3 squared, so that would equal to 4x plus 3 multiplied by itself, right? So now I was just, when you stopped me, I was just working out what this is. So I was just multiplying out the brackets, right?
Okay.
4x times 4x will give you 16x squared. That same 4x times 3 would give you positive 12x. 3 times 4x gives you another positive 12x. And 3 times 3 gives you 9. I'm just going to simplify this now by just adding the two middle terms, plus 24x plus 9. So what I have found right here is what is g of f function. Understood?
Yes, ma'am.
That's all I have found. The question, however, is not yet finished, because the question had asked us to find, initially the question had asked us to find g of f minus 3. So now that I have what g of f is, I can now substitute it for minus 3, right? I can find the negative 3 input of that domain value. So that would be, I'm just going to write it just to carry it up here. So g of f minus 3 equals to 16x squared plus 24x plus 9. So 16 times minus 3 squared plus 24 times minus 3 plus 9. So this now is just maths. 16 times 9 plus minus 3 times 3 is going to give you 9. So 16 times 9, let's go for my calculator. That's 144. Did you get that? Just confirm that that's 144 for me, please. You got 144 as well?
Calculator block off.
Not hearing you.
Calculator went down.
Okay. I'm almost sure it's right. I just want confirmation, just in case I'm making
Yes, ma'am.
I like
Sorry.
to double check. All right. And then 24 times -3 gives you -72. And so the answer to that now would be 144 minus 72 plus 9 should give you 81. So that's the answer there. I'll just give you a second to write it up. I'm coming. All right. We can also work it the second way. I'm going to clear the screen to work it the second way. Oops. So we can also work it the second way where so everybody understand that first way?
It's a little bit more, it's a little complicated, but getting there.
It's more complicated. Yes, it is. I agree. But we're going to work some more questions. So you don't have to worry too much as yet. If when we finish work more questions now you don't understand, then we can start worry. All right. So the second way now is to do it one function at a time. Meaning you first find f of f function minus 3 first. So let's do that. So f of minus 3 is equal to the f function is 4x plus 3, right? Let me just highlight the f function. That's our f function, yes? Remember it, 4x plus 3. And we're going to be putting minus 3 into this function. So anywhere you see x, you put minus 3 plus 3. 4 times minus 3 is -12 plus 3. -12 plus 3 should give you
-9.
Excellent. Thank you. -9. So this is our f of 3 function, right? So this red part that I highlighted here is -9. So now you're going to find g
of 9.
You're going to find g of 9. That's what you're going to do now. So g of -9, the g function is x squared. So -9 squared. 9 times 9 is 81. No, so 9 9 is 81.
Yes.
So that's 81, which is the same as we got for the first answer.
I think I prefer this method better.
Yeah, you can prefer this method better, but most questions will ask you to find the function first. Anyway, most questions will say find f of g or find that of that, and then they ask you. So, but while this is easier, and I agree it is easier because you do it one step at a time, you know, you don't try and run from finding the composite function because you most absolutely will be asked to find it. You almost always will be asked to find it. Before they give you a number, they will tell you to find the composite function first. So you have to just practice to find both. All right, to work it both ways. Well, this way is easy, but it's just more the practice is for the composite, the compound way. All right. Any questions before we move on to our next example? We have one more in this same question, so we'll work that first. All right. So the last question in this one says to find f F2. So you have to put F function into F function. So you have to first put this, so put the F, this F into that F. So put on your F function first. So f of x is 4x plus 3. And then you're going to put the f into it. So anywhere you see the x, you put the f of x function, yes? So right here, so you're going to put the f of x function because you're putting this f into one f. So we're going to go 4, put the f function, which is 4x plus 3 plus 3 out here. So then you're going to have to work out this algebra box right here, which would be 4 times 4x gives you
16x plus 12 plus 3
times 3 gives you
equals 18x plus 15
16x
plus
plus
15.
15. So that is the f of f function. So we have found the f of f function. So now I'm going to just carry the question up here. So now we need to find f of f, this two function. All right. So let me just put back my f of f function. So I'm putting in 2 now. 16 times 2 is 32 plus 15. That should be 47. Yes?
Yes, no.
47. Or we can see if I can squeeze it up like here. Or we can say, let me just put R, f of f2, let's put f of 2 first, which is 4 times 2 plus 3 is equal to 8 plus 3 equals to 11. So that is f of 2. So then we're going to put this f of 2 now into the f function. So f of f2 is equal to 4x plus 3 equal to 4 times 11 plus 3 equals to 44 plus 3 equals to 47. Any questions so far?
Not yet.
Giovanni and Amoy?
Yes, miss.
I'm just asking if you have any questions concerning the
No.
composite function so far.
No, miss.
No, Giovanni? Giovanni sleeping? It would seem. All right, another question. Giovanni? Thought I saw your mic open a while ago. F of x equals to 3x plus 2. And then g of x. So this question now, Shauna, is the reason why you must learn to work out the composite function. So it's asking for f of gx g of f x. All right, so those are all functions. So I'm going to walk you through them. So I'm just highlighting our f function. and our g function. So these are the two functions that we're going to be working with today. Well, for this question. So let's start with question one. I'm just highlighting them because I'm going to keep all of the questions up here. So that's why I'm just highlighting the one that I'm working with currently. So let's do f of g x, right? So f of g x is saying you're putting the g function into the f function, yes? So if you're putting something, if you're putting some bottles in a bag, you have to first put the bag first. So let's put, and then you put the bottles in it. So let's put the f function first because you're putting g into f. So let's put f first. So f is f 3x plus 2. And you're going to put the g function now into this f function. So anywhere you see x in the f function, you put the g function in it, yes? So 3, there is the x now, put the g function, 4x minus 1 plus 2. So let's expand this bracket. 3 fours, 12x. 3 times 1, negative 1 is negative 3 plus 2. So you have 12x minus 1. That is your f of g function. Understood? Everybody understand that? I don't understand why nobody not answering me now. I'm just going to operate like I don't understand them. All right, so let's move on to the next one, which is g of f x. So in this instance, we have in this instance, we have g, meaning you're putting the f function into the g. So you have to put down the g function first, which is 4x minus 1, and then put f now into the g function. So anywhere you say x, you put the f right there. So that will be 4, f function is 3x plus 2 minus 1. So let's multiply it out. 4 times 3x equals to 12x. 4 times positive 2 is 8 minus 1. So we have 12x plus 7. Understood? Any questions? All right. So we're going to do the third question now. We're running out of colors. So let's do that one. F of f. So let's put down our first f function. F of x is equal to 3x plus 2. So we're going to now put another f function into it. So anywhere we see f x, we put another f function. So it's going to be 3x plus 2 plus 2. 3 times 3x is 9x. 3 times 2, positive 2 is positive 6, and then plus 2. So you have 9x plus 8. Good? right. Everybody good so far? All right, so I'm going to work the last one now, which is no. I'm going to work g of gx now. All right. So let's get moving on that one. So g, so we're putting, let me just write it here, g of gx. So we're putting one g into another g. So let's put down the g first, which is 4 g of x equals to 4x minus 1. So we're putting another g into this function. So anywhere you see x, you replace it with the g function, which is 4. The g function is 4x minus 1. 4 4s, 16x. 4 times
Minus
negative
4.
1 minus 4
4.
minus 1.
16x minus 5.
16x minus 5. Right? So that's that. So that is just some practice on doing the composite function. Just one more thing to note before we go on. So we have these two functions left behind, and I deliberately left them on the screen because I wanted to make a point in case you see it in your exam. So this function, g of g x and f of fx, you can also see it being represented as, or when you're asked to do it, they'll ask you for g squared x, and this would be f squared x. It's the same thing because it will be g times g, like what we have here, and it will be f times f. So these are the same thing. So g of g is the same thing as that, and f of f is the same thing as that. Everybody understanding good so far?
So far.
So we're moving on again, before we pull everything together, before I give you some questions that have everything together. So let me know if you're not understanding one step, because then you're going to start getting into problems later on. Good?
Good so far.
All right. So I'm just going to have to assume that Amoy and Giovanni are also good. So an inverse function, we're going to look at inverse functions now. And I'm trying to find, before let me just write down the steps so you can write them down and then we can talk about them. We can talk about what it represents. All right, so step 1. All right, so those are the steps you would follow if you are finding the inverse of a function, f of x. So those are the steps. So write down those steps. I'll give you a minute and then we will talk about really what an inverse function is and so on and so forth.
2.5. How much are they? Eh? I mean, there's a 1.5. Right, look at one. How much is that?
I'm going to have to move this slide. So I'm just giving you a few minutes to write it off. All right. So let's go. We're still on inverse functions. Just drawing some mapping diagrams to explain the inverse functions for you, sorry. So let's say you had a function f of x. You had 1, 2, 3, and this was x. This is z. So it kind of look like a 2, so just making it know this is z. All right. So let's go ahead now and explain. So we spoke about what a function was earlier, and we use a mapping diagram. Remember when we started, and we used the, the whole example of the tire and the relationship between pressure and volume, and then we mapped the domain to the range, to the corresponding range. Now, this f of x is a regular function. This is the type of functions we've been looking at all morning, right? F of x, right? So let us say we have this function f of x in which one maps to x, which means this would be the domain values over here, and this would be the range value. So I'm saying 1 maps to x, 2 in the domain maps to z in the range, 3 in the domain maps to y in the range. Now, this is a regular function. The inverse of this function, and note it is written f to the -1 up top subscript, yes, superscript -1 of x. What that really represents is just to say it's the reverse of the function. It's just the reverse of it. So it's like you're doing the reverse mapping. So for f of x, you had 1 in the domain would map to x in the range. In the inverse function, the reverse is true. X now becomes the domain and it maps to 1 in the range, and so on and so forth. So I went through just all of that for you to appreciate what the inverse function is. So when you are working it out, you have an idea that what you're really finding is the reverse of the function, the original function, right? Everybody clear on that? So let's go ahead now and see if we can work out finding some reverse of some functions here. So we're going to start with, and we're going to just be using the different steps, right? The steps that we found, the steps that we identified earlier. Those are the steps that we're going to be using. Alrighty. So let's f of x is equal to 5x plus 2. And it says find f inverse of x. All right. So going by our steps, let me just write out the function first. Going by our steps, f of x is equal to 5x plus 2. So the first step says to replace f of x with y. So instead of having f of x here, we put y equals to 5x plus 2. That's step 1. Step 2 says replace all the x's with y's and all the y's with x. So where I have y, I'm going to put x. And where I have x, I'm going to put y. That's step 2. Everybody following?
Yes, ma'am.
Step 3 says solve the equation for y. So you have your y right here, so you're going to solve for y, which is what we call make y the subject of the formula, yes? So I'm going to do that by carrying over the positive 2. It becomes minus 2 equals 5y. And then I have to divide both sides by 5, which is the same as carrying over the 5. It becomes a negative. It becomes a divide, sorry. I equals the x minus 2 over 5. So I'm just going to carry this up here. Y equal to x minus 2 all over 5. And then the last step says replace y with f inverse of x. And that is that. Simple enough. All you have to do to find the inverse is just to follow the steps. So I'm going to do one more with you before I give you some questions of your own. And what I'm going to do is just to give you some of the questions you've done before for you to find the inverse. Give you a All right, so let's go with
Yeah. What you really talking about?
all right, so find the inverse of those 4 for me. I'm going to give you 3 minutes, one for each. Follow the steps and see if you can get the answer. I'll work through them just the same, but I'm giving an opportunity to do them on your own. All right, let's go. I almost forgot about you. I was scanning some documents to put in the group so that we're going to use to finish up our class and completely forgot, got carried away. All right, so let's go. Let's find the inverse function. Again, finding the inverse function is really as simple as following the steps outlined. So we're going to do it for question I, first one. So f of x is, we're finding the inverse for these functions. This one is f of x equals to 6x plus 5. So the first thing is to replace f of x with y.
Y.
So y equals to 6x
X plus 5.
plus 5. Replace all the x's and the y's, interchange them. So this becomes x equals to 6y plus
Y plus 5.
and then we can solve now for y. So we're carrying over the 5
So
first.
over the 5.
X minus 5, and then that's going to be divided by 6. I just shortcut because of the space. Sorry about that. Equals to y. So we carry over the y first, which is x minus y, and then we have to divide both sides by 6, which is how we get x minus 5 over 6. Questions?
You want me to stop?
What about other two people in the class? Let them not say nothing. Giovanni and Sean and Amoya, are you there? Amoya, sorry for misspeaking your name. All right, let's do the next one. G of x is x squared. So g of x equals to x squared. Replace g of x by y. So y equals to x squared.
Equals to X squared.
Replace, interchange the x and the y's. So x equal to y squared.
X equals Y squared.
And now we have to solve for y, make y the subject of the formula. So
You get a negative X squared negative minus 2.
no, but this is a square.
Oh,
This is a
you
square.
have to square both.
So you have to find the square root of both sides. So it's the root of x is going to equal to y. And so the answer would be, so
Y.
we need to, we know the last step for this, f inverse of x is equal to that. And this is G inverse. All right. So that is that for this one. So this is how we make y subject of the formula. Remember, if you have a square root, if you have it squared and you want to get rid of the squared, you have to find the root of both sides, and then you'll end up with, so the root of x equals to y, which is the root of x is equal to the inverse, the G inverse function, right? So I'm going to just get rid of, so I can work the last one. Well, last one on this question. So the third one says h of x is equal to x squared. This one is tricky. Minus 4x. I shouldn't get this one, this one is going to give a problem. Probably should leave it. I'm going to leave it. It's going to give it too much problems. And I actually made up this one, So I'm going to leave this one out. I don't want to give it too much problems this morning. So let me leave that one out. I'm going to give you some more. Some non-made up ones, because I made up all of those just now. All right, so let's work this one. All right, so three nice ones for you guys. So I'm just going to give you some time to work it through. I'm going to scan some documents, just some questions that we're going to end our class with. We're going to work through them, put them in the group, and then when we come back, we work through these, and then we work through those questions as well, all right? So I'll give you the time to go ahead and attempt these ones for me, please. So let's just work through these questions first. So the first one should be pretty fundamental and easy for you, because all you would need to do is to apply the steps, right? Everybody agree with me? So let's apply the steps. So f of x is 5x plus 3. So the step said replace f of x with y. So y equals to 5x plus 3. The next step is to interchange the x's and the y. So wherever you see a y, you put a x. Wherever you see a x, you put a y. And then you go ahead now and solve the equation for y. So x minus 3 equals to 5y. And if you divide, carry over the y, it will come and divide. So it's x minus 3 divided by 5 equals to y. And all we need to do now is to just replace the y with f inverse x, right? So this is our f of x inverse. And what I'm going to do, I'm going to just put it up top here with the rest of the functions, because as you can see, all of them have an inverse in it. And so it's going to be very instructive for us to just keep it so that we can remind ourselves what it is, all right? X minus 3 over 5. So that's what f of x is. All right, great. So we can then just go ahead and work the rest of them. So let us see what this one asks for f of f inverse of x. No, this works the very same way like we were saying before. We're putting, because this is now a composite function. So we're putting f inverse into the f function. So let's put down the f function first, which is 5x plus 3. So the f of f inverse function, anywhere you see the x, it means you're going to put the f inverse, which is x minus 5. So I can also write that to say f, I'm finding the f over 5. That's what I'm finding, right? Because this is the inverse. This is the f inverse function. Everybody seen that? Yes. This is my f inverse function. So I'm finding my f of f inverse, right? So anywhere I say x, I put that f, all right, f inverse. And then we would work this out. This is a multiplication sign. I'm just working it out the long way, because this is 5 times x minus 3 over 5. So if you work it out like you're multiplying two fractions, remember when you're multiplying fractions, then this 5 would cancel that 5 right there. Everybody seen that?
Yes, ma'am.
Then I'll be left with x minus 3 right there. Yes, plus 3. And that would give me just x, because minus 3 plus 3 is 0. All right. So this is what f inverse compound function is. All right. Everybody, any questions for that one? And Shauna, these are the type of questions I was telling you about. You know, first I ask you, if you notice, none of these are asking you to find any input values. They all that is
Yes,
required
ma'am.
of you is just a fact. So, you know, it's a skill that, you know, you have to learn and learn well. So you have here, you found the F
It's the
inverse.
only thing,
Mhm.
because I got the answer, but the only thing I did, I had x minus 3 over 1 plus 3.
X
I
minus
didn't got,
3 over 1 plus 3. Okay, so
after
you
doing the multiplication part of it,
mhm.
I had the one at the bottom thing.
Okay, but you'd have to but
Mm,
if you multiply it out, you could have said 1 times x minus 3 is x minus
yeah.
3. So you know, then you work it out here. So all right, so
Yeah.
good. Any complaints from anybody else? Anything anybody else would want me to just address before we move on? No. No, what did I do? All right, do something wrong here, so no. I can't go back. I can't go back. I don't want to do that. No. All right, let me just do it. Yay. All right, so let me just do it again. All right, so we're going to do the third one, which is F inverse. Let me just write it down. F inverse f of x, right? So this time we're putting the f into the inverse. So we're going to put down the inverse function first, which we found to be x minus 3. Let me just put it. X minus 3 all over 5. And we're doing we're putting in the f function into that inverse, and the f function is 5x plus 3. So this literally is the f inverse into the f function into the f inverse. So let's do that. The inverse function is x minus 3 over 5. And if we're going to put in 5x plus 3 here, it's going to be 5x plus 3 minus 3. So this would be in brackets here. So this is the f function that you're substituting here. And that goes over 5. Yeah. Then you would end up plus 3 minus 3. Those two would cancel out. You would have 5x over 5. And if you divide through by 5, you get x. That is our answer. So our f inverse function is x. And this answer that you see here will always hold. Anytime you multiply, anytime you put the function into its inverse, you always get x. Doesn't matter what the function is. Doesn't matter if it's 3x plus 2, 20x minus 8, don't matter. Once you have it in this format where you're putting the original function into its inverse, it should always work out to be x. All right, so you can probably make a note of that. Anytime you multiply, anytime you have a composite function where you're putting the original function into the inverse function, the answer will always be x. That result will always hold. Good so far?
Yes, miss.
All right, so I'm going to give you a few minutes, just about what time, 11:21, about 10 minutes, and you're going to work through the question that I sent in the group. I particularly want you to focus on, because some of them are pretty easy, so I want you to focus on some of the more complex ones, or the ones that I would think to be a little bit more challenging. So I want you to start at question 5 for me. So start at question 5 and go down. We're aiming to go through questions 5 to 9. Question 10, I'm going to leave you for homework, and then we will pick up with question 10, working on question 10 on Monday. So start at question 5 and go down to question 9 for me. That's what we're going to want to go through before we end our class today. So I'll give you 10 minutes to go through as many of them as possible. And it is okay if you're having a challenge to jump over one, just to, because I want to see, I don't want you to spend the whole time on one that you're not working or you're not getting. I want you to get the practice. So if you're not understanding a particular one, you can jump over it and attempt something else. We're going to go through all of them. I want you to be comfortable enough to do question 10 on your own for homework. So you can go ahead and do that. I'm giving you 10 minutes. So we're given the function f of x and the g of x, and we're first asked to find we're first asked to find f of 5. All right, so f of 5 would be 2 times 5 minus 3, because the f function is 2x minus 3. 2 times 5 is 10 minus 3, so that answer would be 7. Right? The next thing that we are asked to find is g of -3. So let's do g of -3. So g is x squared minus 1. So we're putting -3 squared minus 1. So that's 9 minus 1. Answer is 8. Good. Then we are asked to find the composite function f of g. So we're asked to find f of g x. So we're putting the f, the g function into the f function. So we are basically doing f, and instead of x, wherever we see x, we're going to put the g function, which is x squared minus 1, right? So f of gx would be 2. So we're putting x squared minus 1 where we see x.
X squared minus 1.
Minus 3. So then we just need to work these out.
2x squared.
Good. Minus 2.
Minus 2 minus 3 equals 2x squared minus 5.
Minus 5. Great. So that is f of g x. The next one we're asked to find is g of f. So g of fx. And so we're going to put down, so effectively we're going to have our g function, and anywhere we see x in our g function, we're putting in f, which is 2x minus 2. So put on our g function, which is x minus 2. So the first thing would be 2x
2x squared.
minus 3 squared minus 1. So, no, yes, x squared minus 1. Good. So then we would multiply it out. I like to just multiply it out the long way, just in case there's anybody that, needs that clarity. Because always remember, anything squared is multiplied by itself. So when you multiply it out, you're going to get 4x squared (2x times, what's this, 3 minus 3 gives you minus 6x, minus 3 times 2x gives you another minus 6x, and then minus 3 times minus 3 gives you a positive 9, and then you have this minus 1 out here. So that's equal to 4x squared minus 12x plus 8. All right, just going to erase to get some space. All right, so we're going to do the last one, section 5 or whatever you want to call it now, D, I think. That one is the inverse of F inverse. So we're being asked to find F inverse. So all you need to do this is follow the steps. F of x is equal to 2x minus 3. Remove f of x, we'll change that into y. 2x minus 3. Interchange y's and x. So you have x equals to 2y minus 3. And then solve for y. X plus 3 over 2 is what is equal to y. So this would be F inverse is equal to x plus 3 over 2. X plus 3 over 2. Questions, anyone?
Okay.
Even if you don't work it, and there's a part that you don't understand or whatever, please feel free to express that. All right. All right, so let's go. We're working now on, that was number 5. So we're going to go to question number 6. So question number 6 says that you have a function g of x, and it's equal to x squared plus 4x plus m. And also know that g, if you input 3 into that function, you get a value of 25, right? So then they're asking you, what is g of 4? What would be the value if you input 4 into the function? Now, these are questions that I probably, would prefer to give you to go home and to practice, because I like when you think about them. But definitely you will have some thinking questions, because you're going to get some passive questions as well to go with the question 10. So I'm just going to walk you through how you reason this out and think it through. Now, the challenge with a question like this is that there's an additional unknown in it, right? You have that positive m, that's an additional unknown, and you can't solve with an unknown in it, right? So you have to find what this unknown is. A few things you may know about this unknown. This is in the form of a quadratic. So you know that this is going to be a number. And it may not sound like a big deal, but you use these things to guide you. So if when you get your answer isn't a number, if you get something another x, say it is wrong, because this is in the form of a quadratic. This is supposed to be a number, right? So you get this, and they also give you some other information. They said if you input 3 into this function, right? Even though we don't know what m is, you will get 25. And that is more than enough information for you to go ahead and see what you can work out. Because what you know is that when you do x squared plus
4x plus 4x
plus 4x plus m, it is equal
equals
to
25.
25 when you put g where x is supposed to be. You see that? Because usually anything here, so you put it where x is. So you know that if you put 3 where the x's are, the equation is equal to 25. So you can go ahead and substitute 3 where these x's are. Right? And all this is requiring is for you to just appreciate, you know, what the inputs are and how the function works. So you know that you input this anywhere you say g, the equation equals to 25. You don't know what m is, but you have the output, you have the input, you have the function itself partially. You can find out what m is, and we can go ahead and do that. 9 plus 12 plus m is equal to 25. 9 plus 12 gives you 21 plus m equals to 25, which means that m is equals to 25 minus 21. M is equal to, right, say 4. M is equal to 4. Everybody see that?
Okay.
What did that? M is equal to 4.
Got that.
So you now know what you know that m is 4. So you can go ahead and you can rewrite the function to say g of x is equal to x squared plus 4x
4 times
plus
4.
4. So that is what the function is now. You don't have no unknowns in it. And then you can easily find g of x, g of 4. You can just input 4. So g of 4 would be 4
4
squared
times 4
plus 4 times 4 plus 4, whole heap of 4. So 16
plus
16
plus
plus
4
4, that
equals
looks 36. So that is the answer right there. So just a little bit of reasoning, understanding, using the information you have to work to the information that you are asked for. All right. So let's work. We're going to work up until 12 o'clock and then sir will come afterwards to just give you, I don't think it's anything long because you just have the data. So I suspect it's just, you know, working on your data and stuff like that. So working up until 12. So we're at question 7 now, all right? So question 7 says that you have two functions, h and k. H is 2x plus 3. K, 5x minus 4. And you're asked to calculate three different things, I think. So let's start calculating those. You're first asked to calculate the compound function, KH. All right, so again, you're putting H into K, right? So let's put down our K first, our K function. That is our K function is equal to 5x minus 4. And if you're putting k in it, that means k is going to take the place of any x. So k, instead of the x, you can put the h function, which is 2x plus 3. So it means it's 5 times 2x plus 3 minus 4. So then you're working it out. 5 times 2x is 10x. 5 times 3, 15 minus 4, 10. 10x
Plus 11.
plus 11. All right. So that's the first function, KH function, KH. And I think I'm going to write KH function up here because at the end we're asked to find KH -1. So I'm just going to put it up top where I can see it and remember it. So the function KH equals to 10x plus 11. All right, just for friendly reminder. All right, good. Why is it not working? Second question now is HK. So HK, the compound function HK, which means you're putting a K into the H function. So the H function is 2x plus 3, all right? So you're putting K into it now. So instead of x, you're going to be putting the K function. K is 5x minus 4. So therefore, we are having 2 instead of x. It's 5x minus 4 plus this 3 here. So again, let's multiply. This is 10x. 2 times -4 is -8 plus 3. 10x minus 5. Any questions? Nope. Why did not talk to me this morning? That's okay. All right, so our third question asks for KH2. So before I get rid of it, KH, wait. Oh, KH, all right. So our third question asks for KH. One asks for KH2, and the second one asks for KH -1. So remember, we had initially found KH. This is the KH that we had found. This was our first question. So we have it already. So we just need to now input the information. So KH2 equals to 10 times 2 plus 11, which is 20 plus 11, which is 31. And KH -1, so KH -1 equals to 10 times -1 plus 11 equals to -10 plus 11. -10 plus 11 will give you 1. Questions? That's our second question so far. Second set of questions so far. All right. All right, let's go now. We're at number
7.
Yes, number 7. Give me a minute, please. All right, so number 7 says two functions. No, is that I do a while ago? No, right. Yes, 8. Number 8 I want. Number 8 says if f of x, so we have f of x is equal to x squared plus 4x plus k. And this is similar to number 6 that we did. And f of 2 equals to 13. What's the value of f of 3? All right. So we start with the information we know. F of x, when we input 2, we know that I'm using this information here to initially find out the formula, because what we know about this is that we have an unknown. In this case, our unknown is k. So we need to find out what is k first before we can know what f of 3 is. So as before, we are going to be using the information here to solve, to find out what is k. So what we know is that when 2 is put into this f function here, you get 13 out of it. So we can say 13 is equal to, when 2 is put into it, it is equal to 13. So instead of x's, we're going to put 2's. So 2 squared plus 4 times 2 plus k, right? So this that I have right here will satisfy the information we get here when f of 2 equal to 13. So we put 2's, input 2, we should get an output of 13, and so be able to solve. So this is 4 plus 8 plus k. 13 is 12 plus k. 13 minus 12, because we're carrying this 12 across the equal sign. 13 minus 12 equals to k. 1 equals to k. Everybody see that? Okay. All right. So then the next question, I'm just going to cut this in two. The next question now is what is f of 3? So we know that we just found f of x, right? Just found f of x properly to be x squared plus 4x plus 1. So we can then find f of 3 just by substituting 3 into this formula here, equals to 3 squared plus 4 times 3 plus 1. 3 squared is 9. 4 threes is 12 and 1. I think this is 9 and 1 is 10 plus 12 is 22. Yes, 22, I think. All right, everybody good? Okay. All right. Number 9, which is our last one for today. Number 9 says you have two functions, f of x, which is equal to 5x minus 2. And you also have g of x, which is x squared minus 31. And you are first asked to find the value of f of negative, yeah, f of negative 2. So this one is supposed to be easy. You're putting negative 2 into the f function. So 5 times negative 2 minus 2. You have negative 10 minus 2. This is supposed to be negative 12. So that's the first one. The second one is g of fx. So let me just put this on here. G of fx. So again, this is a compound function. You're putting f into the g function. So wherever I see x in the g function, I'm putting f. So f is 5x minus 2. So the g function is x squared. So already I'm going to have 5x minus 2 squared minus 3. 31. Yeah. Minus 31. All right. So this is a squared. So I'm just going to expand the brackets for the squared. 5x minus 2 times 5x minus 2 minus 31. Multiplying, we have 25x squared minus 10x minus 10x and then negative 2 times negative 2 is positive 4 minus 31. So you have 25x squared minus 20x, and this will give you, I think, negative 27. Yes. Positive 4 minus 31 gives you a negative 27. So g of gfx gives you 25x squared minus 20 minus 27. 20x minus 27. And then the last one is the inverse function. All right, so I'm just going to delete that so we can do the inverse function. So we're doing f inverse. So let's start. F of x is 5x minus 2. And this is us now just following the steps. F of x, replace that with y. So y is equal to 5x minus 2. Interchange x and y's. So this is x equals to 5y minus 2, and then solve for y. So x plus 2, because you've carried it over the equal sign, equals to 5y, and then x plus 2 over 5 equal to y. And so you have x plus 2 over 5 equal to 5 inverse, f inverse, right? So wait a minute, it's f inverse 3. So that is f inverse the function. That's f inverse the function, but the question asks us for f inverse 3. So we found f inverse to be x plus 2 over 5. So we're just now substituting 3 into this inverse function, which is 3 plus 2 over 5, which is 5 over 5, which is 1. Yeah, that's 11:59 and we are done. Good. So any questions? All right, no questions. So Amoy, I can't speak to you about your SBA because you say you don't have the data. So there's nothing that I can do to speak to you about the data, but you guys need to get the data together so that we can sort out the SBA. Otherwise, you're going to be under a time crunch. All right. So just putting that out there. So that needs to be sorted out. There's no point in having that conversation now. So we will see if we can have it Monday evening. Hopefully you will come back, you or Mikisha, or both of you will come back with the data, compile the data for Monday's class, and we can speak about it then. We can discuss it then. So Shauna has fell off, so we are going to have to sort out Shauna's SBA separately because she's gone. So that will be all for our class today. All right.
Okay, miss.
All right, no problem.